Welcome to another TIRIAS cast. I'm Jim McGregor, one of the principal analysts here at TIRIAS Research, and I'm joined today by my esteemed colleague, Francis Sideco, who just happens to be sporting our new cool jackets that we get to wear around when it's cold at CES this year.
It's
So
awesome.
thanks, Francis. Now we're going to be talking today about AI at the Edge, and specifically, you attended the Lattice Developer Conference recently, and really appreciate that. Um, I was kind of down with the flu, so it was great that I didn't have to travel for a change. But no,
I'm sure,
it's
I'm sure they appreciated that as well.
yeah, I'm sure. I'm sure they didn't want me there, but still, we've been talking, we've been publishing on Forbes and E! Times about, some of these design constraints for AI and the fact that you really need to design differently for AI. And while most of us think about it in the cloud and the data center, it also affects the edge. And you really have to design specifically for that type of workload. And now Lattice is doing that. So you want to talk a little bit about, what they talked about at the conference?
Yeah, and it's not just really designed for that type of workload, Jim. It's designed for that environment.
Hmm.
And so the interesting thing about bringing AI to that far into the edge, because people talk about the edge, and depending on where you're coming from, that could be the very edge of the cloud, so it's still a server, or it
Hmm.
could be devices. We're talking about now even further than that, going into the embedded world. And when you get into the embedded world, it's really not about speeds and feeds per se. Obviously, you have to have the performance, but it's about optimization. And so, it's using the right tool for the job. And the more you can, to your point, the more you can um, focus on a particular set of use cases or workloads, the better your optimization is going to be because it's going to be a lot more constrained. So yeah, so with at the Lattice Developer Conference this week, they announced an expansion of their Avant line, which is their mid-range FPGAs, but really more their Nexus line, which they have now a Nexus 2 to expand the capabilities of their Nexus platform, which is their small FPGA platform. And just for our viewers out there, mid-range FPGAs are typically 700 or 750K logic cells or above, and then small is really more, less than 250, 200. So, Nexus, I think, lands at around 220, or Nexus 2, sorry.
Well, and let's put this in a different context for our viewers, and that is the fact that a lot of what they're targeting, and Lattice is the leader here, is
Yeah.
devices that operate in milliwatts.
Yes.
So, they are very well optimized, and Lattice has always been the leader in these really small form factor, really power efficient type applications. That might be for something that's literally embedded in something like a roadway or something, or completely remote, something that has to operate on battery life, not just for days, but possibly for years.
Yeah.
So, uh,
So what's really important, and that's really what it is. So what Lattice is trying to do with Nexus 2 is bump up their small FPGA platform capability to be able to deal with the AI models that are getting pushed down to exactly those kinds of devices. And we're not talking about generative AI here. You're not going to be running an 8 billion parameter model on an edge device. But we're talking about mostly traditional AI, a lot of, especially around image and image sensor input and object classification, things like that. But but the types of sensors that they're looking at aren't just regular cameras. You're looking at infrared, you're looking at thermal, you're looking at a wide variety of different image sensor inputs, for example. But when you get into these kinds of kind of like what you said, there's a lot of power efficiency requirements. There's a lot of size too. So the smaller you can make these devices, the more options the end device designers have in terms of form factor, which is really important because function definitely drives form in this environment. So there's a few things that they've done to do that as they've increased like I said, their system logic cells have gone up by almost double. Um, uh, the power part of the power equation is the on-duty cycle, for example. So what helps with that is being able to bring your device and boot it up very, very quickly. So they did some demonstrations against their competitors of similar capabilities, for example, and they were able to, it was an order of magnitude less, where the competitors were booting up in the hundreds of milliseconds time frame. They were in the tens of milliseconds time frame, which that's very important when you're trying to, in those battery constrained devices where they have to last for years. You're able to basically have everything shut down more often and only bring it up when necessary.
Now, not just quick boot, but they were also, I assume, lower power and much smaller form factor.
Yes, it was a lot. They were a lot lower, at least for this set of devices, right? The good thing about this field is innovation and competition, and I'm sure their competitors are going to have their next version that's going to compete and so forth. But at least at this current snapshot in time, yeah, they were definitely a lot smaller. Part of that is they decided to use a LUT4 architecture, which is a four input lookup table. We might be getting a little too detailed here, but that's a core building block of an FPGA type device. And some other architectures use what they call LUT6 or LUT8, which lends themselves to kind of more complex or higher performing things. But there's a lot of trade-off with that. They decided to use LUT4 for, again, the specific use cases that they were targeting for these small FPGAs. And that helped them to optimize on a lot of vectors that are maybe most valuable, at least in their view, for these use cases.
Now, can you give us a feel for how much they improved this in terms of performance and efficiency? I know that the size increased, but very, very
Decrease.
minimally. Yes.
Oh,
So
increase from Nexus One, yes,
from
yeah,
Nexus 1.
yeah.
So it was a small increase in size, small increase in power, but significant increase in terms of performance. And they did that through a number of vectors. So you want to discuss that really quick?
Yeah, I mean, depending on like from a compute standpoint, it went up to 2x. I think memory bandwidth went up by 4x. So even with that minimal increase in power and performance, or in power and footprint, they were able to generate a lot of extra performance with it. A lot of it has to do again with that LUT4 architecture that they did, the increase in system logic cells, but also they beefed up their interconnects between both external memory but also internally within the system by 4x. The LOT4 architecture, which I'll just talk about a little bit. The other thing that it'll do is one, it's a simpler architecture, so it allowed them to get smaller and do that at minimum power. But it also decreased some of the configuration data bit size that is needed for that type of architecture. So when you do that, it also has implications on the boot time and the power. So these were some of the improvements that they did to try to deliver the enhancements that they were looking for.
That's impressive. So, you mentioned video or image recognition definitely being one of the applications. I would assume anything from, audio detection or audio processing, or any other type of sensors,
Yeah.
really, it really is a sensor hub, if you will.
It,
I think it's
it,
kind
it
of
is. And
ideal.
what was interesting was they even had Dell up on stage with them as a partner presenter for the keynote, and they were doing some things around what do you call it when presence detection of the of the user to help wake up the device and so forth from a PC standpoint. And it's interesting because some of the larger SoC suppliers that are providing the main SoC to provide the compute capability on there, whether it's Intel, AMD, or Qualcomm. A lot of them have that kind of capability built in. But Dell still decided to use kind of a small FPGA to discrete to provide that kind of capability. So that tells me at least Dell is seeing increased improvement in battery life to be able to do those kinds of applications.
Well, and it's important to note that, you know, when you increase the performance of a chip, yeah, you can end up increasing the power. But if you don't use all of that performance, you lower the power. So
Yeah.
the benefit is that, in a lot of cases, they're probably going to see lower power consumption than you did with the previous generation.
Well, the other part of that too is if you're able to do things quicker. So
Yes.
even if you might need to have a little higher power when it's turned on, if you're able to turn it off quicker, the actual area under the power curve is smaller. So you're actually using total less power.
Yes, exactly.
One other aspect that was actually interesting, especially in embedded, is security. And this is one of the first commercial devices I've seen that's actually implementing post-quantum cryptography in their security root of trust. And what's important about this is because these kinds of embedded applications typically have a 15 plus year life cycle.
Hmm.
And when you look at what's happening in quantum computing, uh, you know, I think consensus estimates out there from pretty much the whole industry is we're going to have cryptographically relevant quantum computers by around the 2030 timeframe. So that's well within that 15-year life cycle window that these devices are getting designed for. And the important thing that's happening now is a concept called harvest now, decrypt later, where because we're within that time frame of window, bad actors are starting to actually harvest the data. It's still encrypted. They can't decrypt it now, but once the quantum computers are available to decrypt it, there's still very actionable data that they can get from data that they've decrypted or harvested now. So it's really important, especially with these long life cycle devices, to actually start having PQC or post-quantum cryptography algorithm support. And Lattice was the first one that I've seen since the release from NIST of those standards um, to actually bring it into a commercial device.
That's a very good point. So secure, small, low power, a high performance, kind of an optimal solution.
Well, at least until again, great competition in this area. So at
Yeah.
least until we see the next one from the others, and competition drives innovation. So looking forward to see how this develops. Because aside from the other FPGA vendors, there's other companies out there. For example, like Qualcomm, who's driving into this space from where they're at as well. So it'll be interesting to see how this plays out. I think AI getting brought into the embedded is really driving a lot of innovation in this space.
Well, and when we think of who the other players are, obviously there's Microchip kind of on this end, which has gotten into FPGAs. You've got Altera slash Intel, or soon to be Altera again after
Yeah.
Intel, and AMD, which
Yes.
acquired Xilinx. However, the latter two typically target the higher performance, higher end of the market,
Yeah.
which has really allowed Lattice to really be the leader in this segment. So. Any other key takeaways from the event?
No, I mean, I think we've covered it. It was a great event, and it was. I guess one last thing is they had the biggest number of attendees from a developer community standpoint that they've ever had. And anytime you have a developer conference where there's that much interest, that's always a good thing because the lifeblood of all of these and we've written about this, Jim, you and I both, is, the engagement with the developer community is critical for these semiconductor suppliers
Yes.
uh, moving forward, especially as AI continues to be a big deal.
Okay. Well, thank you for joining me, and thank you for the recap of the Lattice event. Um,
Perfect.
we're going to have more coming pretty quickly, one on Marvell's recent event, and we have CES coming up pretty quickly. So please tune in. We're going to have our podcast both on our YouTube channel, our TIRIAS cast on YouTube channel, as well as the audio versions on SoundCloud, iTunes, and Spotify. Please like, please subscribe, and if you have any questions or recommendations, please reach out to us. I'm Jim at TIRIASresearch.com, and this is Francis at TIRIASresearch.com. Wow, I can't even say that. And this is Francis at TIRIASresearch.com. Thank you for joining us today, and if we don't see you before the holidays and before CES, please have happy holidays.
Happy holidays.